HDR Insights Series 2, PQ and HLG transfer functions for HDR. In the previous article HDR Introduction, we discussed the benefits HDR high dynamic range brings about in terms of quality of the video. To display the digital images on the screen, display devices need to convert the pixel values to corresponding light values. This process is usually nonlinear and is called EOTF electro-optical transfer function. Different types of transfer functions are supported in different display devices. Regular HD TV display devices SDR, standard dynamic range, monitors normally use BT.709 gamma transfer function to convert the video signal into light. These monitors are primarily designed to display images with brightness range of up to 100 nits candela per square meter. High dynamic range, transfer functions Perceptual Quantizer and hybrid log gamma. HDR defines two additional transfer functions to handle this issue, Perceptual Quantizer PQ and hybrid log gamma HLG. High dynamic range Perceptual Quantizer is an absolute, display-referred signal while high dynamic range hybrid log gamma is a relative, scene-referred signal. This means that hybrid log gamma-enabled display devices automatically adapts the light levels based on the content and their own display capabilities, while Perceptual Quantizer-enabled display devices need to implement tone mapping to adapt the light levels. Display devices use content metadata to display Perceptual Quantizer-coded images. This can come once for the entire video stream static or for each individual shot dynamic. It is expected that under ideal conditions, dynamic Perceptual Quantizer-based transformation will achieve the best quality results at the cost of compatibility with existing display systems. High dynamic range, signal-to-light mapping. The graph below describes the mapping of light levels for various transfer functions. Vertical axis shows the signal values on a scale of 0 to 1, with 0 being black and 1 being white. This is done to make the signal range, bit depth agnostic. Horizontal axis shows the light level in nits of display device. Human beings are more sensitive to changes in darker region compared to changes in brighter regions. This property is also exploited in high dynamic range systems, providing more granularity in darker regions compared to brighter regions. The graph above depicts that light level range in darker region is represented by a larger signal value range compared to the brighter regions, meaning more granular representation in darker regions. While this is more evenly distributed for the BT.709 base displays, it become less granular for high dynamic range displays in the brighter regions. In case of hybrid log gamma, more than half of signal values are represented for light level between 0 to 60 nits, and the remaining signal values are represented in 60 to 1000 nits range. Similarly, in case of Perceptual Quantizer ST2084 base displays, approximate half of the signal values are represented for light level between 0 to 40 nits, and the remaining half of signal values are represented in 60 to 1000 nits range. According to the graph, high dynamic range hybrid log gamma is similar to BT.709 in lower brightness regions, therefore offering a better compatibility with the existing static dynamic range display devices. However, high dynamic range Perceptual Quantizer is quite different from BT.709. If we try to display the Perceptual Quantizer high dynamic range image on a static dynamic range display, darker regions represented by Perceptual Quantizer will invariably become brighter, thereby reducing the contrast levels of the image. While Perceptual Quantizer-based transforms offers promise to display best quality results on high dynamic range-enabled monitors, in comparison to hybrid log gamma, it requires proper tone mapping by display devices. Definitions. Candela per square meter. The candela CD is the base unit of luminous intensity in the International System of Units SI, that is, luminous power per unit solid angle emitted by a point light source in a particular direction. A common wax candle emits light with a luminous intensity of roughly 1 candela. Nits, a non-SI unit used to describe the luminance. 1 nit is equal to 1 candela per square meter. HDR, High Dynamic Range. It is a technology that improves the brightness and contrast range in an image up to 10,000 candela per square meter. SDR, Standard Dynamic Range. It refers to the brightness and contrast range that is usually available in regular, non-high dynamic range televisions, usually with range of up to 100 candela per square meter. This term came into existence after high dynamic range was introduced. WCG, Wide Color Gamut. Color gamut that offer a wider range of colors than BT.709. DCI-P3 and BT. .2020 are examples of wide color gamut offering more realistic representation of images on display devices. EOTF, Electro-Optical Transfer Function. A mathematical transfer function that describes how digital values will be converted to light on a display device. OETF, Optical Electro Transfer Function. A mathematical transfer function that describes how the light values will be converted to digital values, typically within cameras. OOTF, Opto-Optical Transfer Function. This transfer function compensates for the difference in tonal perception between the environment of the camera and that of the display. PQ, Perceptual Quantizer, is a transfer function devised to represent the wide brightness range up to 10,000 nits in high dynamic range devices. HLG, Hybrid Log Gamma, is a transfer function devised to represent the wide brightness range in high dynamic range devices. Hybrid Log Gamma is quite compatible with existing static dynamic range devices in the static dynamic range. Thank you for listening to our podcast. For more details, visit our website to find extra resources.